So before I move on to equilibrium or balance, one last thing I want to talk about with hearing is that how your voice sounds differently to you than it does on a recording. So if you ever heard a recording of your voice, you notice it sounds a little higher pitched than how you hear yourself. And that's because when you hear your voice through a recording you're just hearing it as the way I talked about it, through your ears and so on, and that's how you interpret that sound. But when you are making the sound yourself, you're not just hearing that sound come through your ears, you're also hearing it vibrate through your body, and especially through your mandible. And so as it vibrates through your mandible, this actually causes you to interpret the sound as being a lower pitch than what it actually is. And this is why we all hate the sound of our own voice in a recording. But I have to tell you, that's how everyone else hears our voice. Now, one of the things you can do next time you talk is to just put your hand upon your mandible here, and you can feel the vibrations going through your mandible. All right, let's get now on to equilibrium. So, two types of equilibrium. One type is called static equilibrium. This is a maintenance of balance when the head and body are motionless. So static, not moving. All right? So what this does is it senses the position of the head. So this occurs in the vestibule, which is this area right here of our inner ear. All right. So if we look inside the vestibule, we're going to see a couple of chambers in there. All right. So these chambers, one is called the utricle. We find here. So right there is a utricle. The other one is a saccule found there. Now the utricle up here projects horizontally, and it's going to detect linear movements, so this kind of movement here. All right, saccule right here projects horizontally, so up and down, and it's going to detect vertical movement, so when I go up and down like so. All right, both of these contain this thing, which is known as a macula. Now the macula is made of hair cells and supporting cells, and above those hair cells and in contact with those hair cells is this structure right here, which is a gelatinous material. So think of a gelatin, like Jell-O, but thicker, all right? And in there, it has these otoliths, these small little bone chips. And those bone chips are gonna add weight to it, okay? So this is what we have. We have one of these maculas in the utricle, and we have another one in the saccule, all right? So, let's move on to this picture here. So if I have a head movement, so like we see here, so this is the macula here, all right? So if I have a head movement, right, and I look down like so, gravity is going to pull that gelatinous material, and by gravity pulling that gelatinous material, that's going to trigger those hair cells. And so they're going to send a signal to my cerebellum to have body adjustments there. I'm also going to use input from my eyes and also stretch receptors in my neck to know if my head is tilted or if my body is tipping. All right, so more than one thing there. All right, the next type is called dynamic equilibrium. In dynamic equilibrium is being balanced while you're moving. So this is a maintenance of balance when the head and body are suddenly moved or rotated. And this occurs in the semicircular canals. So here are the semicircular canals. And at the base of each canal is really where this occurs, because there we have these structures known as the crista ampullaris. So at the base here we have these swellings. That swelling is called an ampulla. So that whole structure there where it swells is called the ampulla. When we look inside of the ampulla, we have this structure here. It's called the crista ampullaris, which is a group of hair cells and supporting cells once again. And those hair cells are going to project into this cone-shaped projection, cone-shaped gelatinous material known as the cupula. So this is gelatinous material again, all right, and then, the hair cells are in there. Now we have endolymph on either side of that cupula, all right? So, just want to talk about water a little bit. So if you have a glass of water and you start walking and then you stop all of a sudden, that water will continue to be in motion. It will spill out in front of you. Or if you have that glass of water and you turn very quickly, that water, being at rest, will stay at rest, and so it will spill behind you. okay? So that's what we're talking about. We have this fluid in here that's going to eventually move that cupula. So when we have a head movement, you know, a typical head movement, like we all do this kind, all I need is this, you know, just a thing turning, all right? So this looks at movement of the semicircular canal with the body movement. So if I turn my head this way, all right? So if I turn my head this way, here's the cupula, here's the end of length. So if I turn my head that way, the end of length is going to bend the cupula in the opposite direction of the head movement. But that's going to trigger those hair cells, and those hair cells are going to send a signal to the cerebellum for a body adjustment. All right? Now, how we get motion sickness is we get motion sickness because we're getting conflicting signals going to our brain about our state of motion, right? So if you get car sick, you know, a lot of people get car sick because they're looking down at something and their peripheral vision is telling them that they're moving, but the other parts of their brain are saying they're not moving. All right, and so our brain deals with this is to think that we have something upsetting our stomach and we become nauseous and we might throw up there. Okay, and that's really what it is, just conflicting signals there. If you've ever played with a kid, taken them, spun them around, set them down, and you see them dodge all the different ways, you know, it's because you got this endolymph moving in their semicircular canals, and when you set them down, that endolymph will continue to move for a little bit, which will bring bending that cupula, and it'll send wrong signals to their brain about where they need to put their legs and feet.